Alright, welcome back. I haven't made a video in a while, and so I gotta stay ahead of the curve, make sure I'm getting this material out there for people who need it. But anyway, we're gonna do lesson 42, and it's renaming fractions using 1. There's a problem that a couple of you have asked me about on the homework, and it goes something like this: 4/4 minus 3/3. And I think people are trying to solve it, like finding a common denominator and doing stuff like that. But there's a different way to solve this, and it's very simple. All you have to remember is that 4 over 4, or anything over itself, it's the same number on top and bottom, numerator denominator, same number, equals 1. So 4 over 4 equals 1. Well, in that case, what would 3 over 3 equal? Well, that would also equal 1. So this is really 1 minus 1, which equals 0. So 4/4 minus 3/3 equals 0. Alright, so let me talk about that for a little second. If I were to draw this out real quick, here's a pizza cut into 4 parts. And here's a pizza cut into 3/3. That looks like a peace sign in there. That's a little bit small, but imagine these all were the same size. This is basically asking, here's a pizza, and it is cut into 4 parts, and here's a pizza, and it's cut into 3/3. If I take a pizza minus a pizza, regardless of how it's cut, the answer is still going to be 0, because I had a pizza and I took away a pizza. So just know that 1 can take a bunch of different forms. You can break this down further into 8/8. Or you can break this down into Alright, so whatever you do to the bottom of a fraction, whether that be multiply or divide, you have to do it to the top of a fraction. And we use this when we're reducing fractions. So let's start with an easy fraction like 3/6. Now I want to divide the top by, what's the greatest common factor of 3 and 6? That would be 3. You divide the top and bottom of this fraction, numerator. If you divide the numerator by 3 and the denominator by 3, you're going to get an equivalent fraction. And we call this reducing. So 3 divided by 3 is 1, 6 divided by 3 is 2. So basically what we're saying is 3/6 is equal to 1/2. And we call this reducing. But there are situations in which we will need to enlarge our fractions. And we do this when we're trying to find a common denominator. This lesson is the precursor lesson to finding a common denominator. And we'll do more on that later. But what I want you guys to know is that 3/6 equals 1/2. And if you start with 3/6, you can reduce it to 1/2. But you can also enlarge a fraction. So let's say we start with 1/2. And we want to increase that to any equivalent fraction that's equal to 1/2. So I can multiply this by 4. If I multiply the numerator by 4, then I have to multiply the denominator by 4. Okay? Basically what you're doing here is you're multiplying 1/2 by 4/4. You're multiplying it by a fraction that equals 1. And 4 over 4, like we just said earlier, equals 1. So if I multiply 1/2 by 4/4, then you're going to get 1 times 4 is 4, and 2 times 4 is 8. So basically what you're saying is 1/2 is equal to 4/8. These are two equivalent fractions. Now I just enlarged this fraction instead of reducing it, and I would do this in situations where I needed a denominator of 8. But we'll talk more about that later. We just want to practice enlarging fractions. So let's do a couple on our own. Alright, so here's a couple fractions that we're going to enlarge. I'm going to take 1/2, and I want to multiply that by a fraction that equals 1. And I can pick any fraction I want that equals 1. There's a numerous amount of fractions that I can use. I can use 2/2, I can use 3/3, I can use 4/4, I can use 1,000 of thousandths. It doesn't matter. So let's go ahead and use 8/8. I'm going to use 8/8 to multiply this fraction. So 1 times 8 is 8, 2 times 8 is 16. Notice 1/2 is equal to 2/16. I've just enlarged that fraction, and maybe I enlarged it. I picked 8/8 because I knew if I multiplied 2 times 8, I would get 16 in the denominator, and I wanted 16 in the denominator. This is hypothetical situation here. So if you wanted 16 in the denominator, what would you multiply 2 by to get 16? And the answer is 8. And if you multiply the bottom of a fraction by 8, you got to multiply the top of a fraction by 8. 1 times 8 equals 8. So what if I wanted a fraction that had, let's say, 12 in the denominator? Okay. So what would I multiply 3 by to get 12? 3 times what number equals 12? And your answer is 4. Okay? So, but if you multiply the bottom of a fraction by 4, then you have to multiply the top of a fraction by 4. Notice, 4/4. That was one of our answers. We can multiply, when we're expanding or enlarging a fraction, you can multiply the fraction by anything that equals 1. 4/4 equals 1. So 3 times 4 is 12, 2 times 4 is 8. This is saying that 2/3 is equal to 8/12. These are two equivalent fractions. Alright, I'll do a couple more and then we'll move. Alright, here's one. What would I multiply 5/8 by if I wanted to get an equivalent a fraction that's equivalent to 5/8 that has 16 in the denominator? Well, you ask yourself, we have a bunch of different fractions that equal 1 over here. Which one of these fractions do we want to use? Okay. Let's go with, well, if I pick 5/5, that means there would be a 5 on bottom. 8 times 5 does not equal 16, so I definitely wouldn't want to use 5/5. The answer, of course, is 2/2. So I want to multiply 8 times 2 to get 16. And if I multiply the bottom by 2, then I have to multiply the top by 2. 5 times 2 is 10. So in this case, 5/8 equals 10/16. Those are equivalent fractions. And I know they're equivalent because I multiply top and bottom by 2. And 2/2 is equal to 1. Alright, here's another one. Let's do 2/3. And I want to multiply that by something that will give me, let's say, 21 on bottom. Alright, so what number times 3 equals 21? I'll give you a second to think about it. I'll give you a hint. It's one of these fractions over here. The answer is 7. 3 times 7 equals 21. Another way you can think about this is ask yourself, 21 divided by 3. What's the answer to 21 divided by 3? And of course, that answer is 7. 3 times 7 is 21. If I multiply the bottom by 7, I've got to multiply the top by 7. 7/7 equals 1. So there, we're using that fraction right there. 2 times 7 is 14. Okay, so 2/3 equals 14/21. And this is how you can enlarge a fraction. You guys have been doing a lot of reducing. Now we're going to do some enlarging. Alright, example number 5. I have 1/3 and 1/2. And I want to multiply both of these fractions by a fraction that gives me 6 as the denominator. So here we have 1/3. What do I need to multiply 3 by in order to get 6? Or what's 6 divided by 3? And of course your answer is 2. So we're going to use 2/2 there. Because 2/2 is a fraction that equals 1, that when we use it and multiply it by 1/3, it gives us 6 in the denominator. So 3 times 2 is 6, 1 times 2 is 2. 2/6. 1/2. What is a fraction that we can multiply 1/2 by to get 6 in the denominator? Or you can ask yourself, what is 6 divided by 2? 6 divided by 2 is 3. Okay, so we're going to use 3/3 because we always want to use a fraction that is equivalent to 1. So we use 2/2 and 3/3. So 2 times 3 is 6, 1 times 3 is 3. Now, if we were adding, don't look at anything over here, if we were adding 1/3 plus 1/2, you could not add these two numbers because they have different denominators, or these two fractions. You cannot add 1/3 plus 2/2 because those two fractions do not have a common denominator. And remember, we always need a common denominator when we're adding or subtracting fractions. So if you do this little algorithm, basically what you've learned in lesson 42, renaming fractions by using 1. Use this little algorithm. You can rename a fraction that's equivalent to 1/3, 2/6. 2/6 is equal to 1/3. And then you can rename 1/2 as a fraction that's equal to 1/2, but only it has a 6 in the denominator. Now, when you add 1/3, wait, that's not 1/3, that's 2/6. Yeah, it is. They're equal. So when you add 2/6 plus 3/6, you can get 5/6. Now we know that 1/3 plus 1/2 is actually 5/6. So that would be your answer. So this is the reason that we're doing lesson 42. Alright, hopefully that makes sense. I do not have my math book. It's at school right now. So I won't be doing any homework help, but hopefully these lessons are self-explanatory. Next week I'll be including homework problems on the videos. So I will see you guys in class. Have an awesome weekend.